Okay, this is for Algebra 2. It's complex numbers, day 2. Remember, complex numbers is when you start having i's because you have a negative under the square root. You can't take the square root of a negative number, so you pull an I out. Remember that I is equal to the square root of negative 1, and I squared is equal to negative 1. So basically, anytime you see I squared in an equation, you could replace that with a negative 1. When you're adding and subtracting complex numbers, you simply combine like terms. It's nothing new. Just like 3x plus 2x is equal to 5x, 3i plus 2i would be equal to 5i. Okay? Anything with an I is like terms and gets combined. A conjugate. We've talked about conjugates a little bit before. It's the same stuff, but the opposite signs. So like x plus 2 and x minus 2 are conjugates. Dealing with complex numbers, if you had 3 plus I and 3 minus I, you have conjugates. Remember when we dealt with conjugates, we just had to do first minus last. You didn't have to do the complete FOIL because the middle two are going to cancel. On this one, you would have x squared plus 2x minus 4, and those cancel. So anytime it's a conjugate, you don't have to waste your time. Just do first minus last. X squared minus 2 times 2 is 4. This one, if you do your first minus last, 3 times 3 is 9, minus I times I is I squared. And we're going to talk in a little bit about how to handle the I squareds. Okay, when you're adding and subtracting, we said you just combine like terms. If there is an addition between the parentheses, they're doing nothing. That's just like saying 6 plus I plus 4 minus 5I. So your like terms would be your 6 plus 4, 10. Your I minus 5I. That's like saying 1 minus 5, negative 4I. Bam, that's all there is to it. When you have a negative, that negative has to be distributed. In other words, you're changing the signs after it. So 8 plus 3I comes down. It becomes minus 6 plus 2I. Now you're going to combine your like terms. 8 minus 6 is 2. 3I plus 2I is plus 5I. This one's different because they're touching. The parentheses are touching each other, which means that you have to multiply. Do FOIL or distribute. Take your 2 times everything. Take your negative 5 times everything. So 2 times negative 4 is negative 8. 2 times 2i is plus 4i. Negative 5i times negative 4 is plus 20i. And negative 5i times 2i is minus 10i squared. Okay, I told you earlier, when there's an I squared, technically you could replace it with a negative 1. So this little part right here would be the same thing as saying negative 10 times negative 1. And we know that negative 10 times negative 1 is a positive 10, right? So there's your proof. Now just accept it, and any time you see an I squared, change that to the opposite sign, drop the I squared. So instead of minus 10I squared, it's plus 10. Again, go find your like terms. Negative 8 plus 10 is 2. 4i plus 20i is plus 24i. Same thing, got to distribute. So 3 times 4 is 12. 3 times negative 3i is minus 9i. Negative 2i times 4 is minus 8i. And negative 2i times negative 3i is plus 6i squared. There is that I squared, so this right here becomes minus 6. Like terms, 12 minus 6 is 6. Negative 9i minus 8i, use your calculator because of signs, minus 17i. Okay, deal with complex numbers. When you have a radical, you can't have the radical at the bottom of the fraction. When you have an I, can't have an I in the bottom of the fraction. So this 2 plus 3i in the bottom is not legal. To get rid of it, what you do is you multiply the top and the bottom by the conjugate of the bottom. So the top gets multiplied by 2 minus 3i, and the bottom gets multiplied by 2 minus 3i. On the top, you have to do FOIL, or distribute, all of it. So 3 times 2 is 6, minus 3 times 3i is 9i. minus I times 2 is 2I, minus I times minus 3I is plus 3I squared. But I know that this plus 3I squared has to become minus 3. So that becomes 6 minus 3 is 3. Negative 9I minus 2I is minus 11I. That is the top of the fraction. So you have to do all of FOIL or distribute on the top. On the bottom, we're multiplying by the conjugate. The 2 in the middle are going to cancel. All you got to do is first minus last. So 2 times 2 is 4 minus 3I times 3I is 9I squared. But I notice that I have an I squared. Minus 9I squared becomes plus 9. 4 plus 9 is 13 on the bottom. Take a minute, look at it, think about it. Alright, so here's another one. This one's actually a little bit easier because there's not as much in the top. 3 plus I is in the bottom, causes a problem. Multiply top and bottom by the conjugate. So 3 minus I over 3 minus I. On the top you distribute. 5 times 3, 15. Minus 5 times I, 5I. You're done with the top. Over. On the bottom, you're just going to do first minus last. 3 times 3 is 9. It's always minus. I times I is I squared. Now, think of this as being minus 1I squared. So this changes to plus 1. 15 minus 5I over 9 plus 1 is 10. Be careful here because all of these will divide by 5. 15 divided by 5 is 3, minus 5I divided by 5 is I, over 10 divided by 5 is 2. That's complex numbers, day 2. Part of it's really easy, part of it you got to think about. Come see me during speed if you have questions.